Hello students, in this video we are going to study about simple machines. So what we are going to study about? We are going to study about simple machines. So what is a machine basically? The machine is an appliance which makes our work easier. Okay, so how it makes our work easier? It makes our work easier. Either it acts as a force multiplier or it acts as a speed multiplier or it helps in changing the direction of effort. Okay, so now let us talk about the simplest machines like lever. So in lever what happens? There are three parts. First one is fulcrum through which anything moves and this fulcrum doesn't move. Second is load, the resistive force which we have to move about. And the third one is effort, the force that we give to the machine. Now if we are thinking about levers, so there are three types of lever. First class, in which the fulcrum is in the middle, like we can take the example of a scissor. Suppose this is a scissor. Okay, so this one is the fulcrum. So scissor is the first class of lever where fulcrum is in between load and here we put effort. Okay, now the example of second class of lever is nutcracker or bottle opener. So in this case what happens? In nutcracker what happens? Load remains in the middle and effort and fulcrum are on the other two sides. While in third class of lever, what happens? Effort is in the middle. What happens? Effort is in the middle. Like human arm is third class of lever. Suppose if you are holding, suppose I am holding this pen in my hand. This is the effort. This one is the fulcrum which remains fixed and this is the load. So effort is remaining in the middle. So it's the third class lever. Now we'll think about mechanical advantage. So what is mechanical advantage? Mechanical advantage is an advantage that we get from the machine. It can be defined as the ratio of load is to effort. Okay. Also mechanical advantage can be defined as the ratio of effort arm is to load arm. So in both the cases we can see this load by effort can be written as effort arm into load arm. Okay, isn't it? So we can write load into load arm is equals to effort into effort arm. By using this we can do calculation. We can do numerical using this formula. Okay, so now the next part that we are going to do is we are going to study about velocity ratio. So what happens in case of a machine? If a question comes that what in a machine never changes. What in a machine never changes? Velocity ratio. Velocity ratio of a machine never changes. It remains constant. It becomes fixed the moment machine is moved. Okay. The moment machine is made, velocity ratio becomes constant. So what is velocity ratio? It is the ratio of distance of effort by distance of load, or even it can be taken as the velocity of effort by velocity of load. We can understand by multiplying velocity into time we will get the distance. So this can be derived from here also. So velocity ratio is the ratio of velocity of effort to velocity of load. Okay, velocity of effort to velocity of load. Now what is efficiency? It is denoted by this. Efficiency is defined as the ratio of work output. Efficiency is defined as the ratio of work output is to work input. Okay, now in case of a machine, efficiency total means either 1 or 100%. But this is not practically, it is practically not possible. Theoretically it is possible. It's possible theoretically we do numericals also taking it as 100% or 1. But practically it is not possible. So why it's not possible practically? Because certain reasons are there. Suppose we are taking a pulley, which is also an example of a simple machine. And with the help of pulley, we are drawing a bucket of water. This pulley is also an example of a simple machine. So in order to make this pulley, 100% efficient, what we need to have? First of all, this pulley should be massless. There should be no mass, which is not possible. Again, this bucket should be massless. Its mass should be 0, which is again not possible. And the weight of this thread, mass of this thread should also be 0. Also, the friction between this thread and this pulley should also be 0, which is also not possible. So for these reasons, a machine can't be 100% efficient. Now let us think about pulley. What happens in case of pulley? In case of pulley, as I have already drawn it, so in case of pulley, what happens? We are applying effort in downward direction. Where we are applying the effort? In downward direction. The tension acts in upward direction. We are applying force in downward direction and the tension is acting in upward direction. So this bucket can be lifted from a well. Okay. So this is an example of a pulley. There are two types of pulley. One is movable, which gives us more mechanical advantage, and the other is fixed. This movable pulley gives more advantage, but fixed pulley doesn't give us much advantage. The formula for finding the mechanical advantage in case of movable pulley is 2 to the power n, where n is the number of pulleys. So here we are not getting any mechanical advantage, but in order to get the direction of effort in a convenient direction, we use fixed pulley. So this one is fixed pulley, and in case of movable pulley, what happens? In movable pulley, this pulley will be there. Then we can connect another one. Then we can connect another one. Then we can connect it over here. So that's a different thing. Now there are more about pulleys. We'll study about that in the next section. I hope you understood this. Thanks for watching the video.